That's Dre's tutoring? Guys, welcome to another video where today we'll be going over lipids. This is a part of the group that I made a select amount of videos going over carbohydrates, nucleic acids, and also lipids. Oops, and I forgot proteins. These are all macromolecules. Now wait, before you guys get on me, there is some debate on whether lipids are macromolecules, and we'll go over that in just a minute. So what exactly are lipids? There are these large molecules that have hydrophobic characteristics. Now, some of the most common lipids that you guys are aware of are ones that are found in the cell membrane. You guys have seen these little guys before, where we have a hydrophobic tail. And again, we'll go over this more in detail in the next slides. And then also we know a good much about fatty acids and knowing that they can be saturated or unsaturated. So we'll be going over all of that in these next few slides. And if you guys haven't already, I highly recommend looking at the last video talking about carbohydrates, because there will be some terms that I've talked about and I'll kind of quickly go over, but there are other videos that talk about it more in depth. Alright, so again, what are lipids? They are a diverse group of hydrophobic molecules. Let's look at this word, hydrophobic. Hydro meaning water, hydropump like Blastoise and Pokemon, if some of you guys don't know. And then phobic meaning afraid, scared, hydrophobic. So these lipids, they have a hydrophobic characteristic. They are scared of water. They hate these guys. They are insanely scared. So this photo that we have here is oil and water. Oil does not mix very well with water. It hates it so much that it will completely separate itself from water. Okay, so that is just an example. Oils and fats, lipids. Lipids hate water. They are hydrophobic. Now let's get into some of this debate here. There are some debates on whether this group is considered a macromolecule. The reason being is because they do not form polymers. So if you guys remember in our other video talking about carbohydrates, these carbohydrates are made up of polymers, and this whole polymer is made up of something called monomers. Even in proteins, protein synthesis, and these large proteins, they are made up of polypeptides. And these polypeptides are made up of amino acids. So lipids don't have this very special polymer type of thing going on. Rather, they have something else that they use to link together. And before we get into that linkage, here's just a bit more points that we want to go over, because we want to throw lipids in that macromolecule category. We don't want it to be, shy and anything like that. It deserves some love too. So again, like we said, they are hydrophobic. They hate water. And because of this, they mix poorly with water. So here's a better image here where we have water at the bottom, and we can see the oil separating from that water because it completely hates it. It just wants to be away. Like dissolves like. We have these water molecules where they link together and they want to be together. And anyone that knows me well is I love water and its characteristic because it is very electronegative. At least the the oxygen is. And because of this electronegativity, what we have is this molecule being very polar, and it interacts with other molecules and other things that it likes. Therefore, it can dissolve and mix well together. But that is a no-no for oil and lipids and fats, and that's mainly because it is nonpolar. And what's causing this nonpolarity is the hydrocarbons. Okay, now wow, would you look at that? Consists of hydrocarbons. What is a hydrocarbon? It is a long chain of carbons and hydrogens together. This is called a hydrocarbon. Just think of a long chain with carbons and a whole bunch of hydrogens. This is a big characteristic of lipids, and we'll see more of this in the next slides. There are different types of lipids as well. There are fats, which can be also fatty acids, We have phospholipids, which we've seen a little bit of before with the cell membrane and the hydrophobic tails. And then steroids. These are an example would be cholesterol, where it's like a precursor to many other hormones, right? So now let's talk more about fats, the generalized definition of fats, and all about fats, right? They are large molecules and they are not composed of polymers. However, this is very big, and my favorite part, they still form by dehydration reactions. In the previous video, I talked about dehydration reactions and condensation reactions, which just means a loss of water. And we'll see more of what that means in the photo down below. So fats, let's not get that confused. Fats are composed of fatty acids. Glycerol and fatty acid make up a fat. So to our left, we have a glycerol with a hydroxyl group. And if we look to our right, again, this is what makes up a fat. We have a glycerol and a fatty acid. So a fatty acid is a fat. But to make a fat, we need glycerol and a fatty acid. So what happens is we have this hydroxyl group and this hydroxyl group form an ester linkage right here. And what happens is this is a dehydration reaction. When this hydroxyl group and this hydroxyl group covalently bond, a water is lost. It's very similar to protein synthesis and carbohydrate synthesis, where these big macromolecules are formed through the loss of water. And eventually what we have is a long chain here, right? And when when we form these three long chains, it is called a triglycerol. 1, 2, and 3. Okay, so fats are made up of glycerol and fatty acids. Now, if we go over to our fatty acids can be unsaturated or saturated, which will be in the next slide. So fatty acids are these long carbon skeleton, about 16 to 18 carbons, okay? They have a carboxyl group, hence it's called a fatty acid. If you guys see here, it has that special COOH that I talk about. It's always COOH, where we have a carbon double bond to an oxygen and then an oxygen and a hydrogen. This is a carboxyl group or carboxylic acid. So therefore we call it a fatty acid, right? So another thing that I want to mention about fats is you'll hear fats and triglyceride. They're typically interchangeable when we mention fats. That's another little thing that I just kind of wanted to highlight there. But yes, fatty acids. When we have three of them together, again, we have a triglycerol. And this is our fatty acid, okay? So now, saturated and unsaturated, we'll keep this very simple. Fatty acids can be saturated or unsaturated. Saturated meaning there are no double bonds, so it is very flexible. It's just a hydrocarbon, plenty carbons and hydrogens, no double bonds. Unsaturated fat has a kink. There is a double bond there. So there's many kinks that prevents the molecule from packing together. So this is an unsaturated fat. Unsaturated fats have double bonds. Saturated fats have no double bonds, and they're very flexible. If we go on to our phospholipids, these are essential to cells and make up their membrane. So as you guys can see here, this is the phospholipid that we're talking about, where it's very important in the cell membrane, where we have hydrophobic tails. We can see a hydrocarbon, and it's connected to our glycerol, and then this phosphate group, and this is considered the hydrophilic head. The hydrophilic head is different from the hydrophobic tails. Hydrophilic means water loving. Hydrophobic means hates water. So what we'll have is this cell membrane here, and we can see our little squiggly guys here, where we have the the hydrophilic head, and then the hydrophobic tails. And this is very important in the cell membrane, where we have to allow certain things in and out of the cell. It is semi-permeable. It is very selective on what comes in and out of the cell. And these phospholipids are very, very important in regulating what comes in and out of the cell. Lastly, we have steroids, our last type of lipid, and one of them being is cholesterol. So this lipid consists of 4 fused rings, and you can always tell a hormone. You'll typically see, again, 4 fused rings, and I like to call these the hidden hydrogens. There's always hidden hydrogens here, and this is still considered a hydrocarbon because within that ring is a carbon, so on, well, hydrogen there, and so on and so forth. There's actually a carbon right smack dab in the middle. And cholesterol is a precursor to which steroids are synthesized. So this precursor can be used for many other hormones in the body, and that are, very important, which is produced in the liver, by the way. So without going too far into it, these are lipids, guys. Again, they are part of, in my eyes, the macromolecule family. They are formed through dehydration reactions. However, they do not have, the special polymers. However, they still are humongous, just like any other macromolecule. They just lack, a few characteristics. Okay, so that concludes this video. I wanted to make it quick about lipids. The next video will probably be about proteins and wrapping it up with nucleic acids. Proteins I'm not sure about because I have so many videos, and again, if you know me, I will do a 2-hour video about it. So I'll see you guys next video. I hope you guys like this one. Peace.